Ah, crap. Carbon dioxide. Okay, morning people. Let's see where we were. We were with we finished digestion up to stomach, right? So if you want to briefly review it. How come there isn't anybody? Okay. So what is digestion? Digestion is the breakdown of complex substances into simple substances with the help of enzymes, right? So since we finished with this, the buccal cavity, where is it? So this is just a review paper because we have finished it in the previous class. In the buccal cavity, we know that 30% of the starch is hydrolyzed to maltose. This is a disaccharide. And the enzyme is the enzyme, people? Talent, you should know. Or it is also called as salivary amylase. This is the carb digestion that happens in buccal cavity. The digestion itself consists of two processes, right? Not just the chemical process with the help of the enzymes, but also the mechanical process. We know the mechanical processes. What are they? Mastication, deglutition, chewing, swallowing, and the peristaltic movements that we see from right from the esophagus all the way to the rectum. So now we are only going to concentrate on the enzymatic actions, the chemical processes of it, because I'm not going to go over it again. Next comes the stomach. So what happens in stomach? You know that in stomach there are two enzymes that are produced as proenzymes, right? What are they? They are pepsinogen and prorenin. There are two ends, people. Remember that. These are proenzymes. That means they are produced in the inactive state. They are converted to an active state in the presence of HCl, acidic medium, into pepsin and renin. What happens? The renin, kids drink a lot of milk, right? Milk contains a protein called casein. This renin, in the presence of calcium, it produces calcium caseinate. Now this is acted upon by pepsin and converts this calcium paracaseinate into peptone. Okay, but that's not the only thing that we observe in the stomach. What else do we have? The pepsin also acts on proteins, and it is connection. Okay, I guess we got the connection back. So let's see, where were we? We are down to 6:55. Still not getting connected. Why? What seems to be the problem? Okay. Okay, sorry about that. I guess this is the time when the power goes off every day, at least when I'm here in the house, or at least when we want to do the class. So where were we? Yes, proteosis. The proteins are converted by pepsin to proteases and peptones. These are not the end product of proteins, but these are partly broken down before they are broken down to amino acids. The proteases are a little bigger than peptones. Are we getting it? Okay. This kind of sucks. So that's what happens in the stomach. The stomach is very acidic due to the presence of HCl. HCl also aids in killing the bacteria, and the enzymes that are present in the stomach, which is pepsin and the renin, they act in an acidic medium. If the medium is alkaline, then we don't see this byproduct. We don't see. Okay. So, and there is also a lot of bicarbonate that is produced by the cells in the stomach, and the mucus, along with this bicarbonate, help to stop the excoriation. Excoriation means what? I mean, eating away of the wall, stomach lining. So the mucus, bicarbonates, start eating it away. Okay? YouTube is not receiving enough. Connection successful. Goodness me. I guess we need to hurry. I don't know. I'm just going to take the class. We'll look at the glitches later on, okay? Maybe we'll get better as we go along. So that's about the stomach. Now comes to the small intestines. What happens in small intestines? It is reconnecting. Bear with me, people. This really sucks, but what can you do? So first thing we want to see about is carbohydrates. The three components, right? Carbs, proteins, and fats. So let's look at carbohydrate digestion in small intestine. So we know a little bit of it is 30% of it is digested, right, into maltose. Maltose is a disaccharide. Now these carbohydrates are acted upon by pancreatic amylase. And this is converted to disaccharides. What are, it is not receiving enough video to maintain smooth streaming. Oh my God. This sucks. Maybe we should go back to Zoom class. What do you think? Okay, for now, we'll just continue this, whether you get it or not. Okay, the disaccharides are, it stopped. Shit. Okay. Maltose, sucrose, and lactose. Maltose, the stream's bitrate is lower than the recorded bit.